All right, welcome back everybody. Today we're going to be talking about standard SR3, so simplifying radicals 3. 2 days ago we learned about how to simplify radicals. Yesterday we learned about how to add or subtract radicals. Today we are going to learn about how we multiply radicals. So looking here at problem number 1, the biggest thing to tell you about radicals is that we have inside numbers and we also have outside numbers. Let's find outside numbers. These would be outside numbers, right? So these are the outsides and these are the insides. The way you multiply radicals together is you multiply the like parts together. If there are no like parts, then those parts don't get multiplied. Here's what I mean by that. On problem number 1, these are both inside numbers, 4 and 36. They're both inside the square root. So when we're being asked to multiply these, we can certainly combine these together. So 4 times 36, I'm going to grab a calculator to help me out. 4 times 36 is 144. Since that came from the inside numbers, it's going to stay on the inside. Just like always with radicals, we do want to go through and simplify if possible. So 144 would break into 12 and 12. 12 is 6 and 2. 6 is 3 and 2. 2 is an ending, 2 is an ending, 3 is an ending. 12 would be 6 and 2, which would be 3 and 2. So I can rewrite the square root of 144 as, looks like I have 2, 2, another 2 2s, and a 3, 3. So I can pull out a 2, I can pull out another 2, and I can pull out a 3. So on the outside, I'm going to have 2 times 3. And as you see, there's nothing left inside of our square root. Those are all gone, so our square root disappears too. 2 times 2 times 3 ends up being 12. Let's go on to do another one. So here's problem number 3. Looking at problem number 3, again, we can multiply the like parts together. These are both inside numbers, so we can multiply them together. 2 times 6 is going to give us 12 on the inside because it came from the inside numbers. Now when you get to 12, just like always, you want to simplify. So 12 will become 4 and 3, and 4 is going to be 2 and 2. So I can rewrite the square root of 12 as 2 times 3. I can pull out anytime I have 2 of the same. I can put a 2 on the outside, and I'll still have that 3 on the inside. So 2 square roots of 3 will be my final answer. Here's another one. This one we start to introduce the outside number. Now, this always gets a little bit confusing for people, but think about this like a negative 1 here. And you could also think about this as having a 1 in front. These are now both outside numbers. So when we multiply these two together, you always only multiply the like parts. So negative 1 times a positive 1 will give us a negative 1 on the outside. And then we will still get an inside number too. And that inside number is going to come from multiplying the two inside pieces. So 5 times 5 is 25. Now, 25 could be broken into 5 and 5, which means I could rewrite this as negative 1 square root of 5 times 5. And we could do our 2 for 1 special and pull out a 5. So I'll have negative 1 times 5, which is negative 5. Nice job. Let's do another one. Look at number 7. This is where the difficulty cranks up a little bit. Remember, to do these, you want to multiply the outside numbers together. That's going to form your outside number. And then you're going to want to multiply your inside numbers together, and that will form your inside number. 3 times 2, these are both the outside numbers. So that's going to give us a 6 on the outside. 10 times 15 is what's going to give us our inside number. 10 times 15 is 150. Once you've combined those two together, your job is still to simplify. So if you come over here and try to simplify this, 150 is 50 and 3. 50 is 25 and 2, and 25 is 5 and 5. So we could rewrite this as 6 square roots of 2 times 3 times 5 times 5. You always want to look for any 2 for 1 specials. I can pull out a group of 5s. Remember, these two get multiplied to give us 30. 2 times 3 is going to give us 6, which will be our final answer. Let's look at problem number 9 for a second. When you get to problem number 9, if you notice, there's no outside numbers here. That's fine. You only need to multiply the like parts together. So 8 times 18, which gives us 144. Now, you can break down 144 the traditional way if you want, but if you know what the square root of 144 is, you can actually just write that too. And hopefully at this point, you do know that the square root of 144 is just 12, because 12 times 12 equals 144. Now, if you didn't know that, not every number breaks down nicely, then you could just break this down into 12 and 12, 6 and 2, 2 and 3, 6 and 2, 3 and 2, and then you could really string this out and pull it out the way we've been doing it. So you would have pulled this out as 2, 2, 2, 2, 3, 3, 2 for 1, 2 for 1, 2 for 1. So you would have had a 2, and a 3 on the outside, and when you multiply all those together, you do in fact get back to 12. Right? So if you notice any of those numbers that you're familiar with, you definitely can take advantage of that shortcut. Let's look at problem number 11. Now's where this gets a little bit harder. Just like you know, whenever you see parentheses like this is our sign to distribute. So we need to multiply this to this and this to this. Now, if you look at this first multiplication, square root of 10 times 3. There's no like parts. The outside 3 here can't change an inside 10. But those do still need to go together. So when I get to a situation like this, where those need to be multiplied, this is going to give us 3 square roots of 10. The 3 is just simply going to sit on the outside of it. Notice how the 3 didn't change the 10, and the 10 didn't change the 3. Inside numbers don't change outside numbers, and outside numbers don't change inside. If there's nothing alike between them, you just put them next to each other. Now when I make my second multiplication, the square root of 10 times 2 square roots of 2. This 2 is just going to be on the outside since there's nothing to change it, but since 10 and 2 are both inside numbers, those can be multiplied. 10 times 2 is 20. So when I come over here now, I have 3 square roots of 10 plus 2 square roots of 20. Now we want to simplify if possible. 10 would break down into 5 and 2. And since there's not any 2 for 1 specials, this won't go any further. We'll leave it there. 20 would break into 4 and 5, and 4 would break into 2 and 2. So I could rewrite the second one as 2 square roots of 2 to 5. I can pull out this 2 for 1 special, so I'm going to pull out another 2. 2 times 2 on the outside will give us 4, so I'm going to have 4 square roots of 5, and then this 3 square roots of 10 is just going to drop down. So my final answer will be 3 square roots of 10 plus 4 square roots of 5. Remember, if they don't combine them. That's okay. Here's your next one. Now, when I try to multiply this one out, and I try to make my first multiplication, 3 and 7 are both outside numbers. So those can be multiplied. 3 times 7 is 21. This square root of 2 is just going to be tacked onto here because it has to go somewhere. We can't forget about it, but it had nothing to change it. That's okay. Now, when we make our second multiplication, we're going to have 3 square roots of 2 times the square root of 6. Now, the 3 in this situation doesn't have anything to multiply by, but it has to go somewhere, so it's going to just sit out front. We have the square root of 2 times the square root of 6. These are both inside numbers, so they can be multiplied. 2 times 6 is going to give us 12. Now we just want to simplify if possible. 2 is not going to get any smaller, but 12 can become 4 and 3, and 4 is 2 and 2. So I can rewrite 12 as 2, 2, 3, and don't forget we do have that 3 on the outside. If we do a 2 for 1 special, we can pull out a 2. 3 times 2 is going to give us 6 square roots of 3 plus 21 square roots of 2. Since they don't have the same square root, these are not going to be able to be combined, so this will be our final answer. Let's look at number 15. Looks like we have just a couple left. Again, we want to make this multiplication. So we're going to multiply this to this and this to this. Now, again, we only multiply the like parts, and if there's nothing to multiply, we just tack it on. 3 times 2, those are both outside numbers, so they're going to give us a 6 on the outside. The square root of 7 is just going to be tacked on here. Then we get to the second part of this, the second multiplication. 2 times 5 is going to give us 10 on the outside. Square root of 7 times the square root of 7, these are both inside numbers, is going to give us the square root of 49. 6 square roots of 7 can't be simplified, but hopefully you know that the square root of 49 is 7. So you could replace the square root of 49 with 7 if you realize that. Otherwise, break it down and you should get to the same answer. So I'm going to have 10 times 7, because this 10 is hooked on by multiplication. 10 times 7 is just 70. So I'm going to have 6 square roots of 7 plus 70. Now, I can't combine those together. That's as good as that gets, because the only way to add radicals is if they both have the same square root. This one had a square root of 7. This one did not. So we cannot add those together. This actually just looks like a regular review problem. So let's simplify this down. So 36. 36 is 6 and 6, which is 2 and 3, and 2 and 3. So I could come over here and rewrite it. I'd have the square root of 3, square roots of 2, 2, 3, 3. 2 for 1 special, 2 for 1 special. So I'm going to be able to pull out a 2 and pull out a 3. On the outside, I already had a 3. Here's the 2. Here's the other 3. And my square root is actually going to disappear because there's nothing left inside of it. Negative 3 times 2 would be a negative 6. Negative 6 times 3 would be a minus 18, which will make this our final answer. All right, let's go to problem number 19, last one. We have 12 square roots of 5, take away 45, or square root of 45. There's no multiplying here. This is just a review problem. So how did we do this yesterday? Well, we can only combine these if we have like radicals. If we don't have like radicals, then what we need to do is just reduce it and simplify. So 5 is not going to get any smaller, but 45 can. 45 is 9 and 5. 9 is 3 and 3. So in this particular situation, I could rewrite the square root of 45 as 3 times 3 times 5. Everything else just drops down. At this point, we should take care of any 2 for 1 specials. So we do have a 2 for 1 special right here. We had 2 3s, so let's pull one out. Pull out a 3. Negative 3 times 3, this will be a negative 9. Square roots of 5. And we have 12 square roots of 5. Now remember, if you get to a spot and you have the same square root left, then you can combine them. So if I have 12 square roots of 5, and I take away 9 square roots of 5, then that would leave me with 3 square roots of 5. Because 12 take away 9 is 3. Remember, the square root of 5s don't change each other when you're adding or subtracting them. Only when we multiply will those ever change. Thank you guys so much for watching the full video. If you have any questions, please make sure you are reaching out and getting help. Have a great day.